Hi, everybody. Welcome. Thank you for coming. Today, we'll be talking about how to improve your team's productivity in Unity. Hi again. I'm Gus. I'm a software engineering technical lead based in San Francisco and I work for Unity. Not that. That should be clear, I think. I like to think of myself as a generalist within game software. I've been in customer-facing software engineering roles for more than 10 years now, and have worked with all kinds of game studios, ranging from those who are just starting off with their first mobile game to those working on AAA franchises.
Hello and welcome. I'm Raz. I'm a technical art manager at Unity, and I'm also based in the San Francisco office. As a technical artist with over 12 years of experience in the games industry, I've helped optimize, create, ship numerous game titles on several platforms. And what I enjoy the most is doing performance optimization work and any kind of asset pipeline automation, essentially make good art become easier and faster to make. So with our intros out of the way, I'd like to tell you a bit about what our team does. So what makes us a good fit to deliver this presentation to you on these topics? We're both part of Unity's game studio organization. Our team is essentially composed of very experienced game developers, and we work directly with our customers inside their actual projects to help them throughout their game development journey. And essentially through the services that we offer, that's how we do it. We add new features to games. We optimize performance, like I mentioned, everything from memory to CPU to GPU optimizations. We port games to new platforms, things like going from a higher-end platform like a PC to a Switch, for example, where there's more restrictions on the hardware. And we do things like upgrading render pipelines and so much more. All right, let's talk about the things that you wanted, that you came here to listen to. Gus, please take it away.
Yeah, today we're going to go over just a couple of topics, a little bit of source control, asset importing, project structure, and a little bit more other than that. But we hope that you will walk away today thinking about where you might find additional productivity in your teams. So with that, let's go ahead. First thing is, teams often have to split their method of sharing project data by discipline. Raz and I, software engineers should be familiar with source control, but too often Raz and I see teams who separate and manage their art assets between source control and non-version cloud storage. This often leads to lost art, duplicated work, or just difficult workflows. Source control has been a central pillar in software engineering for a long time. Engineers are introduced to it early, and it's easy to see why it's great for software. It stores history, it lets you roll back changes, and over time it's become more and more collaborative.
Unity offers a solution in the shape of Unity Version Control, also known up until recently as Plastic SCM. It handles large files and large binaries very well. It's integrated with most of your typical development tools, Unity, but other game engines as well, your IDEs, your DevOps infrastructure, or even project management tools, such as Jira, for example. And can be even scripted to work with your DCC packages, such as Maya or Max or whatnot. But why is this also great for content? Other than the DCC integration that I mentioned that you could do, well, you can easily store very large projects, terabytes, right? And individual large files for large binaries, gigs of files. Iterate on them, but also do things like lock them so no one else can overwrite your changes while you're working on them. So beyond the typical backup and iteration opportunities that you find with other version control software as well, the Unity version control software allows you to count on features such as file locking, like I mentioned, but also visual diffs, for example, on images where you can see what has changed from one change list to another. There's a lot more to say about version control, but the first step you need to take is that you should integrate it into your project. Right, so when we first start projects, we tend to start in kind of a bit of a chaos. Maybe we bring Unity samples, or maybe we bring asset store purchases, Or we bring our own baggage from previous projects that we worked on, things like tools or utilities or shaders and assets, and they all kind of end up in the assets folder, right? And over time, this can become a mess. It can become difficult to untangle, and it results in a giant root assets folder that is slow, hard to navigate, and hard to understand. So in the screenshot, I have an example of one of our older HCRP templates adding files, to kind of demonstrate the point. It adds files to the assets folder. Asset store purchases do this as well. In pre-production, you probably don't want to mess with a lot of these and make a lot of changes initially because, one, it's kind of easy to lose track of the changes you made. That's where source control can help you. But two, it's also easy to break fragile packages, right? And things that have absolute paths, for example, coded in them, which then you have to have an engineer find and fix. So how about once you're in production? What should you do? Well, you should establish some rules on how content is organized in your project. How do you structure your code? Where do you structure it? How do you structure your art and your content? For example, do you have a materials folder and a texture folder for every single prop you have? Or do you have a single folder where you have all your materials and textures? Or do you have a single shared folder for all your props? The more you can plan and kind of anticipate your needs and stay consistent, the more you can then automate, and we'll talk about that in a bit. It's important to note that these rules, they are tweakable, but if you do end up tweaking them, you need to also enforce them and enforce them retroactively on things that have already slipped by that deadline. Let's move on to talk more about other things related to project structure. Naming conventions, everyone's favorite topic, right? Seriously though, don't kick this can down the road. It's important to do this really early on in your project. It might not seem important when you get started off the ground, but that's the right time to do it. So why do we think that this is a problem? Not having a consistent way in which you do naming means that everyone can name or not name assets any way they want. It means that naming itself has very little value, right? It means that you cannot automate things using the names. If I lost your interest in the last 30 seconds, it ultimately means that it's going to cost you more time and more money. So hopefully that brought you back in. So what should you do? Well, you should create the naming convention. I have an example there, but you should create a naming convention document in the same way that you would create a coding standard document. Essentially, it needs to encompass all your asset types and have a rule for every subset of every potential asset you may create. The more you can project into the future, the better you'll be, but this is also a ever-changing document. This process can take several days on a small project, but it can obviously take several weeks on a large project. However, you will make up that time, both in not having to think about how you name your assets, but also through the numerous opportunities for automation that you can do through how you name your assets. Over time, the name can imply what import settings an asset gets, how it gets exported, or what wizards can automatically create things like prefabs with the right mono behaviors attached and whatnot. I'm showing a formula here on screen just to give you an idea of some of the things that you should consider, such as categories, for example, props versus characters versus environments, but also asset types, textures, materials, models, whatnot. This is by no means a complete picture, but because each project is different. But essentially, take something like this, apply it to your project, and then also change the content that you've imported from somewhere else to kind of adhere to these rules.
It's not just assets that need untangling, though. Spaghetti code can become a real problem, taking away time from your engineers and causing difficult to fix bugs along the way, and leading to patchwork and even more spaghetti code later on. Think about what your team's core tech is going to be. This might look like creating your own packages, submodules, including some public packages, or even just as simple as organizing your code in the Unity project and adding some assembly definitions in the relevant folders. Do this early. Even if you're currently working on just a single project, think about what code in there could be reused. This becomes especially useful when you're a growing studio and you find yourself needing to prototype for your next project. You don't want to start from scratch each time. Roll over some code, make it easier on yourself. If you do implement your own code, make sure to use Unity's best practices and establish your design patterns early. Much like establishing naming conventions, you'll want to encourage these patterns to be used often. And that will lead to better efficiency in your team. Finally, I know nobody likes tests, but create your unit tests. Make them a part of your culture. Unit tests may feel unnecessary early on, but as you grow, you want to ensure continued success and mitigate risks. It's just a consequence of it. So it bears repeating. And that's it for project structure. Raz, could you start us off on import pipelines?
Absolutely. So I assume you don't want to have to set all your import settings for every asset you import by hand, right? And you could forget to do it on one texture, and it ends up being either too big and too expensive and crashes your game making it run out of memory, or it's too blurry because you chose the wrong compression setting. And more importantly, even if you want to do it every time, and you think you'll do it right every time, which you won't, but if you think you do, you probably don't want to manually do it for every single asset. So that's where the automated import pipeline comes in. And I'm going to be talking about a few ways in which you can interact with the automated pipeline. One of them is presets. So presets is a Unity feature that allows you to save and store a set of settings in a Unity asset and tell another Unity asset how it should behave. Presets are visual, and they require no code to get started. They're mostly useful for simpler projects where you don't need very complex rules and complex rules to apply complex rules. The process seen here on the left side is how you create a preset. All you have to do is select an asset in your project folder, then look in the inspector, and there's a little linear knob that you can open up to then save a preset in your project. Applying it or tweaking the preset first would just require you selecting the saved preset from the project, essentially the second screenshot there, and then tweaking and making any changes you like, and it will automatically get saved. And lastly, the way you apply a preset, you have 3 different ways in which you can do it. One of them would be directly on the asset. The same way you saved it, you would go to the little linear knobs and select a preset that applies for that type of asset. You could do it in code, which I'll show you in a little bit, but you could also do it in the project settings where there's a preset manager that will allow you to set kind of more wide rules. So let's take a look at that. That's the first screenshot on the previous slide, but I also enlarged it here just so you could take a better look at it. In this example, in my project settings, in the preset manager, I've set up a texture importer, so you look at the kind of the middle of the screen there, that has 2 small rules. One is it looks for a underscore albedo string, and it will apply the preset on import on textures that have the albedo keyword in them, or the underscore albedo. While the textures that have underscore normal will get a different preset applied, the normal preset. Hopefully that communicates the point. So let's move on. The second way to customize your asset import is the asset post processor. This is better, in my opinion, and wider reaching than presets, but this requires code to implement. So you can use the asset post processor to inject code before your import using the on-preprocess methods. For example, you can apply import settings on different assets on import, like I mentioned, for the different asset types. And then after import, for example, on the on-post-process methods. For example, you can trigger an asset wizard that automatically creates a prefab model if all the materials and textures match up, and maybe even assigns a mono behavior that forces the prefab to do something. So let's take a look at the sample of that. So in this example, hopefully that communicates well. In this example, we are applying a preset in code using the asset post processor. So we're actually doing 2 things here. So let's dissect it a little bit. I'm using the on-preprocess texture method and essentially looking for an asset called texture preset. Once I find it, I'm assuming there's only one in the project in here. And once I find it, I load it, and in the last line of code, I'm applying it to the asset importer. So this essentially combines 2 of the things that I just talked about. One, it shows you a sample of how to apply a preset in code. That's pretty straightforward. And then 2, it also shows you how you can use the asset post processor to interact with textures on import, right? And essentially, if I were to just remove that one last line of code and use the asset importer directly, I could change things like the texture size or the texture compression and essentially write all of this manually, but have even more complex rules. Okay, so let's talk about one more tangential topic, multi-platform overrides. So essentially, the last part I want to talk about in import is you can have a situation where you've optimized all your import for every asset, you have automation for everything, but you're now shipping on multiple platforms at once. And you need different settings for each, right? What will you do? So for assets such as textures, and that's what I have in the screenshot, Unity also supports overrides for different platforms. In the screenshot, I have one texture asset selected in the inspector, or selected in the project, and in the inspector, I can customize what kind of overrides I get for each platform. So on the left, I have some overrides for the PC, while on the right, I have some overrides for the Nintendo Switch. You'll see that there's different texture sizes and different compression and different formats, what best fits each platform, for example. But as mentioned in the slide there, these are adjustable through code, and that's where the real power comes through. So let's take a look at another code sample. So in this code sample, I'm also interacting with the same method, the onPreProcess texture method. And what I'm doing here is I'm creating a new object called Android overrides here, and it's a new texture importer platform settings. And if you see, I'm naming it Android, capital A, and you can look at the Unity documentation so you can find the keyword essentially for overrides for each platform. But I'm choosing Android here as my example, and I'm configuring so that the max texture size is 512 and texture compression quality is 0, and the texture format is ASTC with 12 by 12 compression blocks. Essentially, I am customizing what my texture override will be on Android. You can see how this is going to be powerful if I start adding more conditions here. So what if right before I apply the settings, what if I check if a texture is named a certain way, or it includes a certain keyword in it, like char, for example, for characters, or it comes from a specific folder, and then I branch off and do different type of rule application depending on what my conditions are. So now you can think about where you go back and think about the project organization on all the naming convention, all the work that you've put in having a structured project, and how that's going to allow you to do more of this automation. And this is just one example. Okay, let's move on. We've talked enough about customizing your asset import pipeline.
Yes, now that you've customized your import pipeline, let's talk about import times. This has been a common pain point historically in Unity, and is especially true for large projects targeting multiple platforms. Every time you switch from one platform to another in Unity, you have to re-import your project. It's a harsh reality. To alleviate the time spent importing, we generally recommend setting up a Unity accelerator. The Unity accelerator will store and deliver asset data to your project over a network connection, helping reduce the time your Unity instance is taking to generate asset data locally. We generally recommend setting up an accelerator instance for each of your target platforms, or ensure that your accelerator has enough space allocated to it to cover all of your target platforms. But that's not all. There's also an import activity window in Unity, which shows you all the information about the import itself. What was imported, why it was imported, what each asset's dependencies are, and most importantly, how long it took to import. This is very helpful to reduce the initial import times, but it's even more helpful when you want to reduce the amount of time it takes to do re-imports as you make changes in your project. Say, for example, you're making changes to a prefab where you're iterating constantly and trying to adjust it just right. Every time you save that prefab, a re-import of that prefab is initiated or triggered. Yeah. And that import takes time. Maybe it's not a trivial amount of time. And if that's the case, then go find out why it's taking a non-trivial amount of time to re-import. tell your team to flag those instances of as issues and go find out and fix them. This will, in the end, save your team a ton of time. You don't want 30 seconds of idle time every minute, every time you change a prefab. So now that we've gone over some import solutions, how about we talk a little bit about customization?
So every project has different tools that it needs. Some tools are tools that Unity doesn't provide. Say you need a skin mesh renderer combiner at runtime, or a texture packer, or an editor tool that deletes manifold geometry and interior triangles and meshes, or a custom map designer for your 2D game. So what do? You have to make your own custom editor tools. Here are some ways that you could go about it. The way that you're probably more familiar with, ImGUI, is the way that has existed in Unity for a while, and the immediate mode graphical user interface system, that's what ImGUI stands for, is essentially a separate way of creating a Unity UI for the editor that is different from Unity's kind of main game object UGUI way of doing UI for runtime. ImGUI is entirely code-driven and is mainly intended for editor UI, as I mentioned. As more recently, we've added the UI toolkit, which is a collection of features and resources for developing UI for both the editor, but also for runtime. And one core difference is that not only, you don't need just C#, or you could just make it in C# code, but it functions better as an assembly of these three different parts. One, the structure, or the UXML file, the style, which is how it shows up on your screen, things like text being bold or the color of buttons, and that's the USS file, and then the C# code, the functionality, as separate. This allows folks who have a familiarity with web, for example, to come in and more quickly pick up how to develop UI for the editor or for the runtime. With the UI toolkit, I made the tool on the right that you can see there. It has it's an editor tool. It has a bunch of custom duplicate layouts. Each were cloned from an initial copy that was pretty bare bones. And then I injected different buttons, different colors for the different buttons, different styling for the text. I wanted to get something that showcased in each time you scroll looked slightly different so that you can see where something starts and where something ends. Let's talk a bit more about other ways in which you can customize your editor.
Well, often we are tempted to add data straight into code, which will require an engineer to go and make those, adjust those for later. You know what might be a bit better? If you could maybe make those changes available to a designer or producer or anyone with the project, really be able to tweak the data themselves and not have to make any code changes at all. Let's make that possible by customizing how the editor presents our scriptable objects. For those unfamiliar, scriptable objects are simply data containers. They're independent from scenes, and they can store any kind of data you'd like them to have. On the left, we have a custom scriptable object containing some game data, health, some damage, multiplier, and some render information. In the center, we can see that our changes from the code on the right has added some buttons to our scriptable object, and we could do anything with those buttons, really. I know this example is a little simple, but think of it in a more complex use case. We might have a designer on the team who has been working on a spreadsheet, tweaking gameplay data, and would like to make those changes, would like to apply those changes to the project itself. We could add a button on the scriptable object that could read from a CSV file and apply those changes in our project. Or we could do the reverse, export the data on the scriptable object out to a CSV file for the designer to consume later. But there are more visual ways of data representation in Unity, and I think Raz could talk a little bit more about that.
Right, so Are you ever in a situation where you just can't figure out why your scene doesn't look just right? So for example, I find myself often fighting the auto exposure feature in HDRP. So essentially, I think of an example where I have a player walking from a dark interior environment into a brightly lit exterior environment, and I allow the auto exposure to kick in, and what happens often is that the scene ends up overexposed. So how do I first see that that's a problem, and how do I debug it? Essentially, I'm going to talk about some of the tools that can let you see these problems and see how to fix them. So you're probably familiar with the drop-down that the scene view has and has had even in the built-in render pipeline that allows you to see different draw modes. For example, in the first screenshot, I just have a wireframe drawing on top of my shaded models, and that's in the built-in render pipeline. Both URP and HDRP contain all those debug options. However, both URP and HDRP contain a few different ones that you may or may not be familiar with. If you go under Window Analysis Rendering Debugger, it will open a window in both URP and HDRP that has different functionality for additional draw modes or render modes or whatever you want to call them that will represent your scene in different ways. So I picked a few here. In the middle example, in URP, I'm showing the shadow cascades view, which allows me to take a look at my shadows in isolation, see the quality of the shadows, see how my different levels of shadow cascades behave. And I can see this without being distracted by other lighting information or by color even from the diffuse textures or albedo textures. And on the opposite end, in HDRP, I have an example using some material overrides to show the albedo only. So in this case, I'm taking a look at just my base textures without any normal maps, without any lighting information. So I can see, for example, if my levels throughout my textures are somewhat even. So these are just a few of the debugs. If you take a look there, you'll see a lot more that allow you to customize different views. And there's a lot more to show here, and even how to make your own, for example. But I'll let you explore that on your own so that we can move on with our presentation.
Right, so one of the most important things that Raz and I do on a day-to-day basis is actually examine profile data. We take a look at memory profiles, CPU profiles, GPU profiles, with or without Unity tools, using native tools perhaps. We cannot stress enough the importance of doing this throughout your development process. But how does profiling improve your productivity? Well, profiling will make sure that you are putting your team's efforts in the right place. You don't want to be wasting your time solving for a problem that doesn't result in worthwhile gains when you're profiling. The more data you have to profile, the better informed you will be about where your bottlenecks are, and the greater impact your decisions will have ultimately. I could talk to you all day about profiling tips and go through all the things we know, but this isn't an all-day presentation, so let's continue on. You know, there were a couple pieces of advice during this presentation that may not seem like the best use of your team's time early on, like running tests, profiling even, or maybe even setting up the accelerator. The project might be small, but the reality is that you don't need to do all that yourself. You could use continuous integration to do it for you. You could have your builds be built on the cloud. You could make sure your new code is running correctly through automation on automated test suites. You could make sure that your new system won't break when it scales up through automated profiling. Ultimately, the lesson is save your time. Let automated systems take care of running these processes for you, and try out Unity Cloud builds or use an in-house automation system or whatever happens to be the best option for you. But I think we're almost out of time.
So over the lifetime of a game, what's important to you and your team obviously will change. And you need to keep up with those changes and with that life cycle. All these tips that we presented come from real projects and firsthand experience. But there are many more that we couldn't get to, and you have to keep in mind that essentially the art and science of game development is a lifelong pursuit. You can find some extra resources by scanning the QR code that I'll leave on the screen for a few seconds here. Thank you so much for coming to our presentation, and we hope you had a good time and have learned some useful tips and you'll apply them to your own games.